This file explores the various methods we learned in Lesson 4.1 for writing linear equations in slope-intercept form. We began by remembering that slope-intercept form, which we first met in Chapter 3, is simply y equals mx plus b, where the number in front of the x, m as we call it, is the slope, and the number added to the x term, or sometimes subtracted, b, is the y-intercept. To apply these concepts, you will be asked to write the equation of the line given various types of information. The most basic question that can be asked is, given the slope and the y-intercept, you might also be asked to write the equation of the line given the slope and a point containing the y-intercept, or you might be given 2 points, sometimes in function form. And then the final possibility from this lesson was given the graph of the line. In the following pages, we will look at examples of each. For our first example, we're going to write the equation of a line given that the slope is negative 2/3 and the y-intercept is 5. Anytime we read, write the equation of the line, if what we're given is the slope and the y-intercept, we will write y equals blank x plus blank. What goes in front of the x is always the slope, so I go back up to the given information and figure out that my slope is negative 2/3, and I record it in the blank in front of x. I then record the y-intercept, which is 5 in this case, in the blank after the x term, and then the cleaned up pretty form of my equation is y equals negative 2/3 x plus 5. Pretty simple. It's a little more complicated when we're asked to write the equation of the line, as we are in example 2, given that the slope is negative 3/8 and the line goes through the point 0, 5. This is less scary when we remember that when we're given a point where the x-coordinate is 0, that means that the y-intercept is the y-coordinate 5. So we really got more information here than we thought when we first read the problem. But we begin by writing y equals blank x plus blank, and we then record the slope in front of x, and our slope is negative 3/8, and the y-intercept in the blank after the x term, the added or subtracted, and it will be added in this case because 5 is positive. So our equation that we write as our final answer in prettiest form is y equals negative 3/8 x plus 5. The next case looks a lot scarier just because we don't see the slope and we don't see the y-intercept specified for us. But here in example 3, we're asked to write the equation of the line through the point 3, 4 and 0, 5. Well, be on the lookout for points like this, because remember, if x equals 0, the number beside it, our y-coordinate, is our b, or y-intercept. Well, we didn't get the slope, so we know we're going to need that, so we may as well do that before we even start trying to write the equation. And remember, anytime you're given 2 points, you can use the formula that we've gone over since Chapter 3, and we'll begin by recording our first point given, which was 3, 4, and we put the 4 over the 3 because the y is always on top and the x is always on the bottom. Remember, in the point, the first number is your x, the second number is your y, so we'll label those if that helps. Again, the y on top means that the 5 goes over the 0 and the 0 goes underneath. We then simplify what we have. 4 minus 5 is negative 1. 3 minus 0 is 3. So this is our slope. Now we're ready to go. We write y equals blank x plus blank, and the number that goes in front of the x is our slope, which was our negative 1/3 that we computed using our formula. So we have negative 1/3 x, and the y-intercept turned out to be b, goes in the other blank. So So our final pretty answer is y equals negative 1/3 x plus 5. The next example is exactly the same information. It's 2 points, but they're sort of in disguise because we're in function notation. Remember when you see the f in parentheses, then we're in function notation where f of x is just y, and x, which is hiding on the inside there, is x like it's always been. So it might be good, since we're not used to this notation, to translate these into notation we're more comfortable with writing them as points. So we'll write this first one as 0, negative 6. Kind of cool how they're still in the same order, x, y. And then we'll write this one as a point, 2, 10. Well, now we have our 2 points, and again we're on the lookout for points like this. Why? Because if there's an x in the zero, if there is a 0 in the x spot, then the other number is your y-intercept. So that is our b. So let's jot that down over here where it's not in the middle of all that mess. B is negative 6. Again, no slope given. So we have to compute our slope. So we use our formula. Doesn't matter which point we start with, but let's go back to the first one we wrote. 0, negative 6. The y is negative 6. The x is 0. So y on top puts the negative 6 over the 0. And we use our other point, 2, 10. 10 is our y. 2 is our x. And then we simplify. And remember, saying negative 6 minus 10 is the same thing as saying negative 6 plus negative 10. If they're both negative, they add, and you keep the sign. And on the bottom, 0 minus 2, if we take away more than we had, it stays negative. A negative divided by a negative is a positive. 16 divided by 2 is 8, so our slope is 8. And we write y equals 8x minus 6. Remember, if you don't need to write it anymore, you don't have to, but if you need it, you can always start by writing y equals blank x plus blank. Fill in your blanks. The b, which is my y-intercept, is always what's added. And the m, which is my slope, is 8x, which gets us back to the same answer we wrote in the box. Sometimes all you're given is a picture of the relationship, and for our function here, we have a line with no points marked. Many times in the book, they'll already have points chosen for you. So, in this case, we don't have that, so we'll choose a couple points. Let's choose this point and this point. Notice how I'm choosing points where the line crosses intersection points on the heavier lines on the graph paper. So like if I had a line going through this point, that would be a good selection just because it crosses the intersection on the graph paper. Well, in slope-intercept form, we want the slope and the intercept. You can't see the slope. I mean, you kind of have an idea because the line's going up that it's going to be positive, but we can see the y-intercept. So let's start there. So let's notice this first. This y-coordinate gives me my b. From the picture, I see that the line crosses the y-axis at negative 1, so my b is going to be negative 1. Well, since we're working from a graph, we don't need formulas to compute our slope. We're going to do that by hand. So let's start here and go up. So we're going to rise 1, 2 steps. So I already know my rise is 2. And then I run 1, so my slope is 2. So I'm ready to write my equation. If you don't need the blanks, you can skip the blanks, but if you like having the blanks, you can start back at this every time. Y equals blank x plus blank. Always in front of x, we will find our slope, so we're going to put a 2 there, and our y-intercept on the other blank. Our final pretty form of our equation is y equals 2x minus 1. And that's pretty much it.